Industrial Hydraulics, Session 1, Basic Principles, Part 2. Flow rate. Flow rate is the volume of fluid flows per unit time. It is usually measured by using a flow meter. The unit used to express flow rate are LPM, liters per minute, and GPM, gallons per minute. 1 GPM is equal to 3.785 LPM. Next, flow speed. Flow velocity or flow speed is the distance a specified volume of fluid travels in unit time. Flow speed is usually measured in centimeter per minute or inch per minute. Continuity equation. If fluid flows through a pipe with different diameters, the equal volumes flow in equal time. Look at the picture. Fluid is flowing through a pipe of different diameters. Take the case 1 where cross-sectional area of the pipe is A1. Consider fluid travels a path length S1 in time T1. Volume V1 is equal to area into path length, that is equal to A1 into S1. Flow rate Q1 is equal to volume per unit time, that is equal to A1 into S1 by T1. That is equal to A1 into V1, where V1 is the flow speed. Similarly, in the second case where cross-sectional area is A2, flow rate Q2 is equal to A2 V2. Now, according to continuity equation, Q1 is equal to Q2. Therefore, A1 V1 is equal to A2 V2, where Q is equal to flow rate in liters per minute, V is equal to volume in liters, A is equal to area in inside area of pipe in square centimeter, T is equal to time in minute, S is equal to path length, and small v is equal to speed, flow speed. Energy law, Bernoulli's equation. The total energy of a flow of fluid does not change as long as energy is not supplied from outside or drained to outside. That is, potential energy plus pressure energy plus movement energy is a constant. Potential energy is related to height of fluid level. In industrial situations, change in potential energy is not significant. That is, pressure energy plus movement energy is a constant. Therefore, an increase in velocity causes a decrease in pressure. Hydraulic power unit. Energy is transmitted in a hydraulic system by the use of a liquid as carrier of energy. The parameters that determine the work capacity of the hydraulic system are flow and pressure. The flow generator or hydraulic pump, usually driven by an electric motor or an internal combustion engine, sucks fluid from a reservoir and delivers to the pump outlet. From there, fluid enters the system and reaches the user, which offers resistance to the flow. Pressure builds up in the system to overcome this resistance. The unit, which consists of the necessary components required for creating this fluid flow against a resistance, is known as hydraulic power unit, sometimes referred to as hydraulic power pack. The hydraulic power unit includes some or all of the following components: a hydraulic pump to create fluid flow, a tank for liquid storage, a motive force for the pump, a device for limiting the maximum pressure, a unit for capturing liquid contaminants, hydraulic lines for connecting the components, a pressure gauge for reading the system pressure. The picture shows the circuit of a hydraulic power unit. Part number 1 is a hydraulic pump which sucks fluid from a reservoir 3 through a suction strainer 4. The pump is driven by an electric motor 2. Fluid from the pump is flowing to the application site. Part number 5 is a pressure relief valve which limits the maximum pressure in the system. This pressure can be adjusted by spring S. The valve is normally closed. When the set pressure is reached, R and R' will be connected and excess oil from the pump will flow to the tank 3. Part number 6 is a pressure gauge which indicates the pressure in the system. Hydraulic system. Apart from components of hydraulic power unit, there are other components, control elements such as direction control valves, flow control valves, etc. and the components in the application side, hydraulic cylinders or hydraulic motors. The entire combination of hydraulic power unit, control elements, and application side components is known as a hydraulic system. Part number 8 is a double solenoid operated 3-position 4-way direction control valve. The central position is its neutral position, and in this position, oil from the pump is connected to reservoir 3. There are two solenoids 9 to actuate the left hand and right hand positions. When the left hand position is actuated, the fluid takes a straight path as shown in the arrows, and oil from the pump is flowing to the back end of the cylinder, causing it to move forward. Oil in the front side of the cylinder is flowing back to the reservoir through the valve. When the right side position is actuated, the fluid takes a cross path as shown in the arrows, and oil from the pump is flowing to the front end of the cylinder, causing it to move backward. Oil in the back side of the cylinder is flowing to the reservoir through the valve. Applications of hydraulics. In today's world, you will find hydraulic applications everywhere. Some of them are listed below. Hydraulic presses, plastic machines, heavy machinery, machine tools, lifts, mining machinery, construction machinery, agricultural machinery, mobile cranes, excavators, automobile construction, telescopes, landing gear and radar control of aircraft, marine deck cranes, steering mechanisms. Some examples of hydraulic applications. The first picture shows a forklift whose lifting mechanism is hydraulics. The second one is a C-frame hydraulic press, which is commonly used in industries. Here is a manually operated hydraulic press, hand operated hydraulic press, and an electric operated hydraulic press. A large extrusion press, hydraulically driven. Mobile crane used in construction sites and ports. Loader. Dumper. Excavator. Advantages of hydraulics. In hydraulics, you can achieve high forces with very compact size. Simple overload protection is possible by using a pressure relief valve. Variable speed. Reversible. A hydraulic actuator can be instantly reversed while in full motion without damage. It is suitable for fast movement processes as well as for extremely slow precision movements. In hydraulics, there is a device called accumulator where you can store hydraulic energy. Disadvantages of hydraulics. Hydraulic systems are costly. Oil leakage poses a problem to users. It is dangerous. Accidents be caused because of higher pressure. Hydraulic oil is flammable. Now, there is an exercise which you need to do yourself. If you have any difficulty, please use the command box. Question number 1. What are the two parameters that determine the work capacity of a hydraulic system? Number 2. How is the pressure created in a hydraulic system? Number 3. Oil from a hydraulic pump enters a distribution block which has 3 outlets A, B, and C. A line connected to a hydraulic cylinder attached to a load and requires 100 psi pressure to extend. B and C lines also connected to hydraulic cylinders under load, and to extend these cylinders require a pressure of 200 psi and 300 psi respectively. Which cylinder will extend first? Why? Question number 4. Which is the device that limits the maximum pressure in a hydraulic system? What will happen if it is not included in the system? 5. A hydraulic pump displaces a fluid flow of 50 liters per minute towards a hydraulic cylinder of 1 meter stroke length. It takes 1 minute to complete the cylinder extension stroke. How long it will take to complete the extension stroke if the pump capacity is increased to 100 liters per minute? Question number 6. A pump is used to create a fluid flow towards a hydraulic cylinder through a pipe. The inside dia of the pipe is 10 cm and that of cylinder is 50 cm. A. If the fluid flows through the pipe at a speed of 100 meter per minute, find the speed of the cylinder extension stroke. B. If the speed of the extension stroke is 10 meter per minute, find the flow rate of the pump. Thank you. Thank you for the kind attention. If you like this video, please subscribe to support and get more videos on not only next sections of this course, but other topics as well.